Hey seniors, today we're going to continue with estimating square roots. So on your notes page, go ahead and draw a line on the left-hand side and write estimating square roots in the top left-hand corner. Don't worry about this yet, just be with me. If I want to estimate a square root, I go through a few steps. And we talked about these steps yesterday, so there is no reason to write this down again. You wrote it down yesterday. We don't need to be repetitive. I would only estimate a number that wasn't a perfect square. So if I was given the square root of 81, I don't need to estimate this because I already know that this number is 9. The square root of 81 is 9. And again, of course, I can always check myself by squaring 9, multiplying it by itself, and that's going to give me 81 every time. However, if I was given a different number that was not a perfect square, say the square root of 102, I have no idea what this number is. So I have to estimate what it is. And if I want to figure that out, these are my steps that I go through. I determine which whole number it falls between, so I figure out what perfect squares are around it. And then I decide which square root or whole number the integer is closer to. And then from there, I estimate to the nearest tenth. So let's go right into some examples. If I want to figure out what the best approximation of the square root of 51 is, I go through the same process as yesterday. I look at the square root of 51 and I think, what are the perfect squares that are around this number? And I think back to my list of perfect squares that you wrote down from Monday, and I recall that 49 is a perfect square and that 64 is a perfect square. The square root of 49 is 7, the square root of 64 is 8. So I know that the square root of 51 is going to fall between 7 and 8 somewhere. So then my next step is to figure out, is the square root of 51 going to be closer to 7 or closer to 8? So let's go back to our numbers that are inside the radicals. 51 is a lot closer to 49 than it is to 64. So I'm thinking that the square root of 51 is going to be closer to 7. And since it's closer to our lower integer, I know that its decimal is going to be between 0.1 and 0.4. So I can immediately eliminate 7.6 and 7.8 because those decimals are too high and they're too close to the number 8. So my next step is just to figure out, is it 7.1 or 7.4? And of course I determine this by squaring these numbers or multiplying them by themselves. So let's just pick one. We'll start with 7.1. Again, when I square it, I multiply it by itself. And of course, you remember from math intervention that you ignore your decimal until the end. 1 times 1 is 1. 1 times 7 is 7. My pen is your pen. Make sure you have this down. 0 placeholder. 7 times 1 is 7. And 7 times 7 is 49. So then my next step is just to add these. 1 plus 0 is 1. 7 plus 7 is 14. Carry my 1. 9 plus 1 is 0, carry my 1, 4 plus 1 is 5. I have two numbers behind decimals, so my decimal goes right there. So 7.1 squared is 50.41. That is pretty darn close to 51. Well, let's go ahead and square 7.4 and check our work. Because maybe 7.4 is a better estimate. All right. 7.4 times 7.4. Again, I ignore my decimal until the end. 4 times 4 is 16. Carry my 1. 7 times 4 is 28, which gives me 29. 0 placeholder. 7 times 7. 7 times 4 is 28 again. And then 7 times 7 is 49. 51. Of course, I just add these numbers. 6 plus 0 is 6. 9 plus 8 is 17, carry my 1. 2 plus 1 is 3, plus 1 is 4. 54.76. 50.41 is closer to 51 than 54.76. So 7.1 is my best approximation of the square root of 51. Let's do another one. Which is a better estimate of the square root of 22? Well, I'm already given I'm only given 2 answers here, so 50-50 chance. Again, I go through the same process. What are the square roots that are around 22? Well, I think back to my handy list, and I know that 16 is a perfect square, and 25 is a perfect square. So of course I know that my number is going to fall between 4 and 5. And 22 is closer to 25, so it's probably going to be a number closer to 5. I'm only given 2 choices here, so I can pretty much eliminate this one almost immediately. But let's go ahead and square 4.7 to make sure that we're correct. And of course, when I square it, I multiply it by itself. 7 times 7 is 49. 32. Carry my 0. 7 times 7 is 28. Carry my 2. 4 times 4 is 16. 18. And of course, I'm just adding. 9. 10. Carry my 1. 8 plus 3 is 11. 12. 22.09. That is pretty darn close to 22. So 4.7 is my answer. My pen is your pen. Make sure you have all of that written down. All right. My last example, and then you guys are going to practice. Graph the square root of 28 on the number line. So the first thing I need to figure out is what numbers are around it. Of course, we see that the number line already shows it between 5 and 6. So in order to do that, square root of 25 and square root of 36 are the closest square roots. 28 is closer to 25, so it's going to be closer, our number is going to be closer to 5 than 6. So I'm only looking at 5.1, 5.2, 5.3, or 5.4 as possible choices. So our next step is just to go ahead and pick one of those numbers, square it, and figure out if it's right. So I'm going to go ahead and pick 5.3. Again, I ignore my decimal until the end. 3 times 3 is 9. 3 times 5 is 15. 0 placeholder. 5 times 3 is 15. 5 times 5 is 25, plus 1 is 26. Of course, I'm just adding these numbers. 9 plus 0 is 9. 5 plus 5 is 10, carry my 1. 6 plus 1 is 7, plus 1 is 8. 28.09. That is pretty darn close to 28. So I can go ahead and assume that 5.3 is a great estimate for the square root of 28. So that's where it would go on the number line. My pen is your pen. Make sure you have that down. All right, guys, I'm going to stop talking now. You guys are going to practice. I feel really good about this skill, and I think you guys are going to do awesome. Cool.